Here we're going to be looking at polynomial inequalities and how we go about setting these up and solving with these. We first need to go through and find our points of interest, and to find our points of interest we're going to start off by moving this over to one side and having it set less than 0. So I'm going to take and first move this 3 by doing a minus 3x to both sides here, which now gives me x squared minus 3x minus 10 is less than 0. At this point we can now factor our trinomial. To factor it, I bring each of these down and I find that it's x minus 5 and x plus 2. So my zeros would be at a positive 5 and a negative 2. So looking at my number line, I'm going to go through and put a circle at negative 2 and a circle over here at 5, positive 5. I've essentially gone through and divided my number line up into 3 separate regions. And I need to look at each region and figure out if I substitute numbers in one of those regions, what's going to happen to my equation up here. Is it going to become positive or is it going to be negative? I'm looking for where it's going to be negative because negative numbers are less than 0. So I'm going to do a quick test over here to the side. Quick little test. I'm going to test negative 10, 0, and 10. I just chose those numbers at random. 10's easy to multiply by. I can easily plug those in and check them. So I'm going to plug in negative 10 for my x. If I plug in negative 10 where x is, so that'll be negative 10 minus 5 times negative 10 plus 2. So both of these are going to be negative. So this one here becomes negative, this becomes negative. 2 negatives makes my final answer positive. This region is positive. Now I'm going to plug in 0 and do the same thing. So coming back over here, I'm going to plug in 0 minus 5 times 0 plus 2. So I have a negative and a positive. Well, a negative and a positive makes a negative. So therefore, this region is negative. And next I'll plug in 10 and check the last region. So I'm going to plug in a positive 10 minus 5 and a 10 plus 2. This one, positive. This one, positive. 2 positives makes a positive. So this region is positive. So everything that I need that makes negative solutions will be in between negative 2 and 5. Or I could write it as negative 2, comma 5. Looking at our next one on here, x plus 1 times x minus 3 squared is greater than 0. So this time, instead of looking for negative, I need to find where the regions are positive. First I find my zeros. Well, this one's already set up so I can find my zeros quickly. My zeros will be at negative 1 and positive 3. So doing a quick check here, do my negative 10, 0, and 10 again, because I have a circle here at negative 1 and a circle at 3, so there are my 3 regions divided up. Region 1, region 2 and region 3, I need to check. So if I put in a negative 10, so that means I'm going to do a quick check of negative 10 plus 1 times negative 10 minus 3 squared. This one is negative. This one is positive. Therefore, that's negative. So here I have negative. If I plug 0 in, that would be 0 plus 1 times 0 minus 3 squared. So I have positive and positive, because when we square it, it becomes positive. So that's positive. This region is positive. I'm going to plug in 10 and check it. So I have 10 plus 1 times 10 minus 3 squared. This part is positive. This part is positive. Positive and positive makes positive. So this region is positive. So therefore our solution would be x is greater than negative 1. Or I could write it as negative 1 to infinity. Looking at our rational inequalities is a similar type process that we have to consider our points of interest, or POI. The points of interest are where our numerator, the top, and the denominator, the bottom, are equal to 0. Those will be our points of interest. So keeping that in mind, we're going to look at this, and so we have x plus 1. So our points of interest, our POI, for this equation, for the numerator, that'll be a negative 1, and for our denominator will be a positive 5. Otherwise, our process is similar to what we just did on our previous inequalities, except here I'm going to go through and circle and put a closed circle at negative 1. I'm going to circle and put a closed circle at 5, but then I'm going to encapsulate this because it cannot equal 5, because that's our denominator and we cannot have zeros in our denominator. So I've now divided this up into my 3 regions, 1, 2, 3. And we don't always have to have 3 regions. We could have just 2 pieces, or we could have more than 3, but in this case we have 3 like we did before. So I'm going to go through and check my numbers like I did the last time. So I have negative 10, 0, and 10 to check, because those are definitely in each of those distinct regions. So if I go in and plug in 10 plus 1 over 10 minus 5. Well, the top is positive, the bottom is positive, positive, gives me a positive. If I plug in 0, 0 plus 1 over 0 minus 5, that's going to give me a positive over a negative, positive, negative, which will give me negative. And then if I go plug in plug in my negative 10. Here, I'm going to have negative 10 plus 1 over negative 10 minus 5, which gives me a negative over a negative. So negative, negative makes a positive. So looking at my regions here, this region is positive, this region is negative, and this region is positive. Therefore, my final solution will be negative 1 less than or equal to x less than 5. It cannot equal the 5 because we cannot have zeros in our denominators. Or write it such as square bracket negative 1 comma 5 parentheses. Looking at our last example here, it's a similar type process. We do have to factor our numerator. To factor the numerator, x squared plus 4x plus 3, that one becomes x plus 1 times x plus 3. So my points of interest for this one, the POI, are going to be at negative 1, negative 3, and positive 1 because of my numerator here of x minus 1. I'm going to go through with this one, and we're going to circle each of these. So negative 1, circle, negative 3, circle, and positive 1, circle. For this one we have 1, 2, 3, 4 distinct regions to look at. So I've got to go and pick my numbers to plug in and check. I'm going to plug in a negative 10, negative 2, 0, and 10. Chose negative 2 because it's in between the negative 3 and the negative 1. If I plug negative 10 in here, so checking my x plus 1, my x plus 3, and my x minus 1. That's what we're checking each of these. So negative 10 in here is going to make this negative. Negative. Negative 10 in here will make this negative. Negative 10 in here makes this negative. 3 negatives makes a negative. If I plug in negative, so that's the region right here, negative. I go plug in a negative 2. Well, this one becomes negative, this one becomes positive, and this one becomes negative. Well, an even number of negative signs makes this positive. So this region is positive. Plug in 0. Plugging in 0, I have 0 plus 1 makes that a positive, 0 plus 3 makes that a positive, and 0 minus 1 is a negative. Odd number of negative signs makes negative. So this region is negative. And lastly, I plug in a positive 10. Plugging in a positive 10, I get positive, 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 which gives me positive because there's no negatives in there anyway. So this is a positive. And we are looking for where this is greater than 0. That means it has to be positive. So we need everything that is going to be from here to here and here on. So we would write that such as negative 3 is less than x, which is less than negative 1, union of 1 less than x less than infinity. Or using our interval notation, we would say parentheses, negative 3, comma, negative 1, union 1, comma, infinity. Rational inequalities and polynomial inequalities. Take your time, set you up a table, and have fun.